Good evening, everyone. Can all of you hear me? Loud and clear? Hello, Jovan, Daniel, Adam, Alia is here, Alvia, how are you, Alvia? Haris, Namira, Irfan, Yumna, how are you, Yumna? How's school? How's Irshad today? All right, so we have Sumaya here, Humaira, Abbas, good, okay, good to hear. Okay, I'm expecting about 50 students. Currently, we only have 33. Okay, as usual, I'll give just 1 to 2 minutes before we start. All right, so how's revision in school? Okay, Jovan, you want me to speak louder? Everyone can hear me loud and clear? Okay, tiring, yes. Mr. Young got echo. Okay, echo probably is due to your speaker. Okay, your speaker, you have to check your system speaker. All right, probably you have your speaker, your microphone. You don't need your microphone. You can switch off your microphone. You only need your speakers. Stressing, yes, Alia, I'm sure it's very stressful at the moment. All right, but just you do not be overly too stressed because it's not a very good time for you to be extra stressed out. I'm sure all of you have done your very best. You have prepared for the past months preparing towards your PSLE, and the time is very, very close for you to have your PSLE written paper. Yeah, 6 more days, Jovan. I know everybody is stressed. Okay, just relax. And now is not the time to be overly stressed. Okay, now is just to be consistent and to revise, browse through your files in all subjects, your maths files. All right. In fact, you don't have to do too many more additional papers. Okay, all you need to do is you have done, I'm sure you have done tons and tons of papers in all subjects, maths, science, your mother tongue, and English. So now is the time for you to review your wrong answers. All right, just go through your wrong answers, check your files. I'm sure you have a very thick file, science file, maths file. Go through the wrong answers. All right, write the correct answers, rewrite them again, remember the facts, what are the keywords, key points. Okay, so I believe at this point of time, there's no need to do, extra papers. We have done more than enough. Okay, now is the time for you to review all your papers, your wrong answers, and for you to remember your mistakes, right? There's no point doing more and more. And then the past papers that you have done, you forget about them. Okay, for maths, the strategies, the different strategies that you have learned, how to draw model, how to use the different strategies, how to solve this particular question. Okay. Okay, Faris. Hello, I can't hear anything. Okay, Huda, can you hear me? All of you, can you hear me? Frozen. Okay, Frozen. Yes, Ayuni, very good. Okay, Hannah. Mine have Mr. Young face. Yes, you should have my face there. Everybody all right? Okay, perhaps it's the internet connection, but no problem. If any point of time during the session, if your system freezes, no problem. Don't worry. I'm recording this and I will upload onto YouTube and share with your parents. Okay. Hi, Haris. You are back. All right. Okay. As usual, I want you to have make sure that you have a piece of paper with you. Okay, a piece of paper and your writing materials. So at any point of time, if you have any questions, okay, please on a piece of paper, and then later on at the end, during the answer Q&A, okay, you can ask me during at that point of time. Okay. All right, everyone, ready? Mr. Yang, try talk. Yes, I'm talking all the time right now. Softly, are you okay? Is your system okay? Yes, I'm speaking all the time right now, non-stop. Probably blackout because of raining. Huh? Is it? Oh, you're having a blackout at home? You sure? So if blackout, then you should not get your internet, right? Okay, there's at my side here. Oh, it's Haris. It's raining at your side. My side is okay. I'm at Yunos area. Okay, no problems here. All fine, softly. Okay, good to hear. It's raining, but the network is fine. So how now, Hannah? What's wrong? Any problem, Hannah? Haris, no problems. Mine just ended. Okay, let's start. Okay, so good evening, everybody. So if parents you are tuning in, good evening to all parents as well. Okay, so in this session, I'm going to share with all of you. Okay, I'm going to start now, students. So please refrain from chatting. All right, because when you chat, it will take up more resources on your PC and the network. Right, it's going to affect everybody. Okay, so I seek your cooperation to during the my session. Please refrain from chatting. All right. We have to be fair to everybody. Everybody wants to learn. Right. If you have any questions, write down a piece of paper. I will leave it up to the very end Q&A session to answer all your questions. Okay, everyone can cooperate. Okay. Now let's start. Okay, so in today's session, I'm going to share with you an answering technique specifically on how to answer graphs question. Okay, and it is very closely related to yesterday's webinar. So those of you who attended yesterday's webinar, we spoke about how to answer or approach experiment questions, right? I give you the various steps, right, to look out for. For example, step number 1, find out what is the aim of the experiment. Step number 2, you find out what are the change variable and what is the fixed variable. Step number 3, okay, you identify the concepts, right? Then step number 4, step number 3, the relevant concepts, and step number 5, explain the concepts and link them to the question itself. Okay. Okay, let's see. A second. Okay. Is everyone okay? All okay? Science Revision Clinic is cool. Okay, very good. All right. Okay. Can all of you stop chatting? If not, I will switch off the chat function. Okay, is it okay? Can, huh? All right. Okay, please focus, huh? Okay, so in graph, now why do we have graphs in science? Why do we have graphs in science? Why do we have tables and data in science? Very, very simple. Because number one, a scientist, if you conduct an experiment, okay, you have to collect data, right? We have to collect data as part of the experiment. And after that, we have to present our findings, okay, to present our findings to other people. So there's no point doing experiment and then we keep it to ourselves. Okay, so the way of presenting, we call this science communication. All right, now how to communicate your science, your finding. Okay, one of the common way is to present your data in the form of table as well as in the form of graphs. Okay, so today we are going to focus on how to answer, how to interpret graph questions. Okay, so graph is very closely related to maths, right? Yesterday somebody asked, teacher, why is maths like science and science like maths? Yes, science is very much like maths, and maths, okay, a lot of maths are involved in science, especially physical sciences, physics. Later, when you go to secondary school, you learn lots of physics topic and lots of maths are involved. Okay, so graph is also nothing new to you because you have learned graphs in math, right? In fact, in primary 1, primary 2, you learn picture graph, and then you move on to bar graphs and then line graphs. In primary 6, you learn pie chart. Now, pie chart is also a graph. Okay, so science is very much, very closely related to math. Okay, so graph. Now, first of all, let's take a look at the graph, the features or the parts of the graph. Okay, before we are able to interpret graph, you need to know the parts of the graphs. Okay, now the graph has what we call axis. Okay, we have two axes, the vertical axis, right? The vertical axis as well as the horizontal axis. Okay, very commonly in maths, we call the vertical axis the y-axis and the horizontal axis the x-axis, right? But doesn't matter at this point of time, secondary school you learn. Okay, what we need to know is that in science, you need to identify what are the variables in the vertical axis and what are the variables in the horizontal axis. What do they represent? This is very, very important, right? First thing, when you see graph, you need to identify the axis, right? What is the vertical axis? What variables does the vertical axis means? And what variables does the horizontal axis means? Okay, right. And another thing very important is that you need to know that the horizontal axis is the cause. Okay, this is the cause, and the vertical axis is the effect. Right. Many students tell me that can we interchange between the horizontal axis and the vertical axis? The answer is no, because in graphs the horizontal axis is always the cause, and the effect is presented in the vertical axis. Okay, so you need to be very, very observant and clear and identify, make sure you have the correct cause and effect. Okay, the correct cause and effect. Okay, so when we want to learn about graph, we want to interpret and analyze graphs. Okay, you must learn a few key terms. Okay, a few key terms. Number one, you need to know the aim of the experiment. Right, we have already learned yesterday about the aim of the experiment. Right, is a statement to describe the purpose of doing the experiment. Right? A statement that describes the purpose of doing the experiment usually start with the term to find out, to investigate. Okay, and the y-axis is the vertical line, and the x-axis is the horizontal line. Okay, and change variable also nothing new. All of you are very familiar. In one experiment, there can only be one change variable. We also call them test variable and the independent variable. Okay, and if there is more than one change variable, it will not be a fair test. Okay, so you must ensure that you only have one change variable. Okay, and fixed variables which remain the same in an experiment. There could be many change fixed variable in an experiment, and the result of the experiment. So this is where we're going to focus on today, which is the data that you collect from the experiment, usually presented in table or graphical form. All right, so far all okay, yeah? Okay, now let's take a look at the various types of graphs in PSLE science. Okay, there are many kinds of graphs, but what are the more common type of graphs? Okay, the first is the line graph. Okay, line graph is very, very common. All right, you have upward sloping, downward sloping, U shape, V shape, and so on. Later we'll take a look at more of such graphs. Second type of graph is what we call the bar graph. Okay, all of you are also very familiar with bar graphs. Right, bar graphs come in different types. Also, it could be vertical this way. It could also be horizontal. Okay, so you must be able to interpret, and sometimes you must be able to draw graphs as well. Okay, please take note. Sometimes in the question they ask you to draw the graphs. All right, and the third kind of graph is what we call pie graphs or pie chart. Okay, this you learn in primary 6 maths, how to calculate problems involve pie chart. Okay, so this is also very common. Example, in the questions where they want to show you various components or quantity or percentage of the various gases in air, they usually show in terms of the pie graph. Yes, pie graph. Are they say pie graphs never used in science? Yes, it is used. This is science, right? Composition of air. So you can see here the composition of air: 21% oxygen, 78% nitrogen. Okay, so it could be, right? Doesn't matter, but you have already learned in primary school maths, right? Pie chart. So they can ask you. Okay, so don't be surprised if you see a pie graphs in science. All right. Okay, so now let's take a look at the various kind of line graph. So you can see this is upward sloping, right? This is downward sloping. Okay, so what does outward sloping means? So as the x-axis increases, as the variable in the x-axis increases, the variables in the y-axis also increases. Okay, for this graph, downward sloping means as the x-axis increases, okay, the y-axis decreases. Okay, the value in the y-axis decreases. All right, so some of you may have seen this, very common. This is an inverted U-shape. This is a U-shaped graph. Now, what does this U-shaped graph means? So it means that as x increases, y decreases up to a certain point. Beyond this point, right? Beyond this point, the value of y increases, right? The y variable increase. So when you are explaining graph, right, you must ensure that you explain all components, all parts of the graph. Okay, now in this graph there are two parts, the downward sloping and the upward sloping, right? So when they ask you to explain or elaborate what happened in the graph, you must ensure that you elaborate both parts, okay, the downward sloping as well as the upward sloping. I remember in our one of the recent papers, right, many students, you only about bacteria, right, you only explain one of the part, right? And the other part, which is also significant, were not explained. So make sure when you elaborate or explain graphs, trends in graph, make sure you elaborate fully, not just partially. Okay, and you have various kinds of graph. This is downward sloping, upward sloping. Now heat graph is always like this. It's always curved, right? Now heat graph is very common in the exam. Okay, and you could see this kind of graph, which is very common, right? This is a melting graph, right? When ice is melting, you can see upward sloping. So at certain point of time, at the melting point, okay, ice starts to melt, right? When it starts to melt, it will be constant. Okay, the temperature is constant, and then the temperature increases again as time increases, and then when it reaches the boiling point, okay, it repeats the same, right? So after that, beyond that, the temperature continue to increase. Okay, so you can see this type of graph also, and you may also see this kind of graph. All right, maybe a slight variation, especially under the topic of environment. All right, webs of life, population. You can see lots of population graph in this way, going up and down, right? Cycles, okay, going this way. Okay. All right. So let's move on. So all of you okay? All of you so far got me? All right. So now I'm going to share with you a table similar to what we did yesterday in experiment question. So when you see any question involving graphs, okay, you can approach or think of these 6 steps. Okay, think of these 6 steps. Step number 1, identify the aim. What is the aim? Where is the aim of the experiment? Right? Remember, sometimes it's clearly given in the question, sometimes it's not clearly given. So you need to identify the aim. Number 2, you need to identify what are the variables in the x-axis and the y-axis. Okay, you must focus, right? Zoom in into what are the variables in the x-axis and the y-axis. So this could be obvious, but many students sometimes, under exam condition, when you see lots of information in the graph, you do not know where to start, right? You must focus on, because time is very, very precious during the exam. So focus on what it says in the y-axis and the x-axis. And then thirdly, you must be able to tell the relationship between the x-axis and the y-axis, meaning the variables in the horizontal line and the variable in the vertical line, right? You must be able to tell the relationship between the vertical, the horizontal axis and the vertical axis. Okay, step number 4, identify the key science concepts, right? Once you have interpreted the graphs, you must be able to identify the science topic and the science concepts that they're testing you in the question. Okay, this is very important. Okay, and of course, before you're able to do this, make sure that the science concepts are all at your fingertips. Okay, make sure all at your fingertips. So you must know, remember, okay, be able to recall quickly under stress or under exam condition, okay, all the various science concepts from P3 topics all the way to P6 topics. Okay, now step number 5, once you have identified the key science concepts, you must be able to link the science concepts to the context, to the question. Okay, you must always link back to the question. Okay, so if you number one, if step number 4, you identify the wrong science concepts, then obviously you are not able to link back to the context. Okay, so you must be able to identify the correct science concepts, and after that, you must link to the question. Okay, and state the step number 6, state the conclusion. Okay, based on the relationship. Okay, you need to conclude based on the relationship. Okay, so I do not, of course, you do not have the time, right, in the exam to, to create a box, a table, and write one by one. Okay, do not do that. You're not supposed to do that. Okay, but this is to help you in the thinking process. If you see any experiment question, any graphs question, right, any experiment question involving graphs, okay, these 6 steps should come to your mind, right? What is the aim of the experiment? What are the variables in the y-axis? Okay, what are the variables in the vertical axis, and what are the variables in the horizontal axis, and what is the relationship, right? Let's say it's upward sloping. What can you tell? Is it as time increases, the temperature increase, for example, or it could be downward sloping as time increases, okay, temperature decreases, right? You must be able to tell the relationship between the horizontal axis, the vertical axis, and the horizontal and the vertical axis. Okay, step number 4, you must be able to identify the key science concepts. Right, you identify the wrong science concept, that's it. Yeah? Instead of evaporation, you identify as condensation, for example. Right, expansion, you identify as contraction. Right, so these are mistakes, right? Common mistakes. So you must have your science concepts at your fingertips. And then step number 6, you must be able to link the science concepts to the question, back to the question they're asking you. So there's always the linking process. And step number 6, you conclude. Make a conclusion based on your understanding and your explanation. Make some conclusion based on the relationship. All right. All right. Now I'm going to show you some past actual PSLE questions, okay, involving graph. There with you the answers. All right. Now let's take a look at this question. Okay, I give all of you 2 minutes to read the question quietly. Okay, Alice set up an experiment in a dark room as shown below. Right, so you can see yesterday there was one similar question. This is another question in past PSLE, right? If you see plants and you see torchlight, so you know that it is definitely they are going to test you about photosynthesis, right? Because light, what is the purpose of light? Okay, light energy is trapped by the water plant, the chloroplast in the water plant, so that it can make food, right? It can photosynthesize to give out oxygen bubbles. Okay, so you can see here, Alice changed variable X, okay, and counted the number of bubbles in the tube. And she kept the other variables constant, and here are the results. So remember I tell you, first you find the A with the experiment. Okay, after that you identify the variables, right? What does variable X stands for, and what does the Y variable stands for? Okay, so you can see here, this is a downward sloping, right? Downward sloping. It means that as variable X increases, the number of bubbles per minute decreases, right? Number of bubbles decreases. Now, what could cause the number of bubbles to decrease? All right, so you have to think and ask yourself, right? How come when I increase the value of X, the number of bubbles decrease? So again, you must link back to the concepts, right? The concept here is about photosynthesis. Remember, the concept is about photosynthesis, and during photosynthesis, we recall that oxygen is given out during photosynthesis. Okay, and what is required for photosynthesis? You know that light is required for photosynthesis, and this light is provided by the torchlight here. Okay, so you can see that as the torchlight, the variable X, it should be the distance between the torchlight and the water plant, right? So as the distance between the torchlight and water plant increases, so you can see from here, as the distance between the torchlight and the water plant increases, right, the intensity of light will be lesser, right? The intensity of light will be lesser. So when the water plant gets lesser amount of light, okay, so you can conclude that it will undergo lesser photosynthesis, right? The rate of photosynthesis will be lesser, will be slower. Hence, it will give off less oxygen bubbles. So that's why you can see that the number of bubbles per minute decreases. Okay, so that's how you analyze, right? You interpret the concepts, right? You must know what concept, the concept on photosynthesis, right? You must know photosynthesis give off what? Oxygen bubbles, right? If you don't know what is photosynthesis or you have forgotten, is it photosynthesis give off carbon dioxide or oxygen, right? Then you definitely cannot answer the question. Or if you don't know what is required for photosynthesis, right? If whether light is needed for photosynthesis, then you are in trouble. Okay, so after you are able to identify the correct variables, then you must answer the questions. Okay. All right, now let's take a look at the answers. I'm going to use the table which I shared with you just now. So identify the aim of the experiment. Okay, identify the aim of the experiment is to find out how the amount of light affects the number of bubbles produced per minute. So in this question is not very clear about the aim of the experiment, right? Remember I told you yesterday, sometimes they want to make it a little bit tough for you. They do not give you the aim of the experiment. So from there, you need to infer, right? From there, you need to infer that what are they trying to test? Okay, so step number 2, identify the variables, right? The y-axis. So from here, the vertical line, the y-axis is the number of bubbles per minute, and the x-axis, you can conclude that is the distance between the torch and the water plant, right? The distance between the torchlight and the water plant, and of course, the ruler here give you a very big clue. Okay, the ruler here give a very big clue. And step number 3, what's the relationship between the two variables? Right, so as the distance between the torchlight and the plant increases, the number of bubbles produced per minute decreases, right? Reason why? Because when the torchlight is further away, the intensity of light is lesser and hence, okay, less photosynthesis and less bubbles being produced. Okay, right. All right, so step number 4, right? Step number 4, identify the key science concepts. Okay, remember in science exam, they want students to show your understanding of the concepts, right? This is not an English comprehension question, right? You must show your understanding of the key science concept, right? For this instance, it is about photosynthesis. So you must be able to recall what is required and what is given out during photosynthesis. Okay, so here you know that light is needed for plants to make food. Okay, light is needed for plant to make food. Secondly, the greater the amount of light, the higher the rate of photosynthesis. Okay, the greater the intensity of light, the greater the rate of photosynthesis. Okay, so in this particular conclusion, it may not be in your textbook, right? You may not know. What you know is only that light is needed for photosynthesis. But in this particular question, okay, they demonstrate to you in the form of experiment that intensity of light also affects the rate of photosynthesis. Okay, so that's why scientists do experiments. They want to find out whether different variables affects photosynthesis or not. Okay, so step number 5. Okay, link the science concepts to the context. As the distance between the torchlight, okay, the distance between the torchlight and the water plant increase, the number of bubbles produced decrease. And number 6, state the conclusion. As the plant receives less amount of light, the rate of photosynthesis will decrease. Okay, so that's how we analyze. This is in the thinking process, right? You must think very fast. Right? In the exam, you got no time, right? You got no time to take you don't have the luxury of time to think a very long time, right? You need to think very quickly because it's only 1 hour 45 minutes and you have to cover 28 questions, right? And the open-ended question as well. Okay, some of you write very slowly, so if you are writing very slowly, please try to improve. Okay. All right, let's take a look at the next question. Okay, now I want to show you bar graph. Again, this is a past PSLE question. All right, bar graph, and in this particular question, they show you 2 bar graphs, 2 in 1. One is the white color and the other one is the black color, right? White here represent the female and the black represent the male. Okay, so Susan studied the percentage of male and females hatch from the eggs of a certain type of lizard at different temperatures, and her results are shown below. What's the relationship between the percentage of female hatch and the temperature? Okay, so question part A is quite simple. Remember our steps is that first we need to identify the aim of the experiment, right? So here Susan studied the percentage of male and female hatch. Okay, and this is the result. So it's not clearly stated. Okay, but what you know is the variables, right? The axis. So the horizontal axis stands for temperature, and the vertical axis stands for the percentage hatch. And this is the key. This is the legend or the key. What does the black color bar graph represent, and what does the white color bar graph represent? So here they ask you what's the relationship between the percentage of the female and the temperature. So female is white color, right? So you can see there is a downward sloping. There is a downward sloping trend. Okay, so you can see, observe from the bar graph, right? Only observe the white color part, right? Because we are interested in only the female. Okay, so as the temperature increase, okay, the percentage of female hatch decrease. So there is a relationship between temperature and the percentage of female hatch. Okay, and part B, based on Susan's results, give a reason why this type of lizard may disappear from the earth due to global warming. Right? How come this type of lizard may disappear? So if you look at the graph, right, after a certain period, right, you can see that as temperature increase, the percentage of female decrease, right? It continued to decrease sharply, right? So as global warming will increase, eventually the percentage of female will become zero, right? So remember, under the concept of reproduction, that's what is required for fertilization, right? You need the male reproductive cell as well as the female reproductive cell, right? So it fertilizes, then it can lay eggs and produce offspring, right? So in this particular instance, if due to global warming, the number of the female become extinct, right? After some time, it become extinct. So how are the male going to reproduce without the female? Okay. All right. So let's take a look at the answer. Let's recap. So question number one: what's the relationship? Very simple. The higher the temperature, right? This is the cost. The higher the temperature, the lower is the percentage of female hatch. This is the effect, right? Remember, I told you the cause and effect. Now, some students may say the other way around. Some students may say the other way around. As the percentage of female hatch decreases, the temperature increase. Now, can we say that? Can we say it opposite? As the percentage of female hatch decreases, the temperature increase. Obviously, no, right? Remember the cause and effect, right? So if you say that, are you telling us that the temperature is affected by the female hatching, right? Doesn't make sense, correct? Okay, it doesn't make sense, right? So the cause and effect is very, very important. So in graph, the vertical axis is the effect, okay, and the cause is the horizontal axis. Okay, now let's take a look at part B. Why this type of lizard may disappear? Global warming causes, what is the concept of global warming? You know, global warming causes a decrease in the earth temperature over a period of time. So eventually there will be no more female hatch, right? If it is to continue. So without female, the lizard cannot reproduce, okay? Because you need both the male and the female reproductive cell to reproduce for fertilization, and hence this will cause extinction. Okay? All of you okay so far? Can, huh? All right. I hope you understand. Okay. And again, if you have any question, please write down on a piece of paper. Okay. And later on, I'll give you time for the Q&A session. Huh? Right. Very good. Okay. We're on track. Huh? Now, let's take a look at this question. Okay. Let's take a look at this question. Can all of you see? Okay. I'll give you 1 minute to read. Huh? Okay. Now this is a past PSLE question, right? Now you can see this is a bar graph. This is this is a line graph, and in this line graph there are two graphs. Okay, so you not only need to interpret the graph separately, right? If they show two line graph in one, you must be able to compare compare, right? Now, many students have problems with comparison question. Many of you fear comparison question. Okay, so you must be able to compare between these two graphs, right? And you must also be observant. Now, why do at this point, this is a very important point, right? Where they start at the same point, you must ask yourself why, okay? And then you must identify what is the horizontal axis, which is the time, which is the cost, and the vertical axis, which is the temperature, right? And this is the effect. So as time increases, you can see, right, the temperature of both, the temperature in both containers increase, right? But however, you need to understand that it doesn't increase in the same rate. Okay, now let's read the question. Okay, so the graph below shows a lamp placed at the same distance between two identical glass containers A and B, and glass container A is left open while container B is covered with a clear plastic sheet. Okay, so you can see it's very important that the lamp is placed right in the middle, right? Because this is what we call the fixed variable, right? Remember yesterday we learned about fixed variable or constant variable, right? Otherwise, it will not be a fair test, right? You have to ensure that the lamp, right, the heat source in this particular question, it is equal distance between the heat source and the two containers. Now, the only change variable here is the presence of the plastic sheet, right? In container A, there's no plastic sheet, it's not covered, but in container B, it is covered with clear plastic sheet. Okay, so once you identify this, then you analyze the graph. Okay, so from the graph, you can see this is the two line graph, graph P and graph Q. Okay, so they ask you which graph P and Q represents the temperature change in container A. Then you need to analyze. Now, what happened here in container A, right? Now, this lamp produces heat, right? So when this lamp produces heat, the air inside both container will gain heat, right? Remember, this is under the topic of heat, right? Heat, remember, under concept of heat transfer from a region of higher temperature to a region of lower temperature, right? Say this is hot, right? The heat transfer from here to the air in the container, right? To the air in the container. So the air in the container gains heat. Okay. Now the difference between A and B is that in the B, the heat here will be trapped, right? The heat here will be trapped. Just a simple example, right? Let's say you are in the classroom, right? In a very hot day. If you are to close all the windows and all the windows and the door, you will feel very, very stuffy and very hot, right? So likewise here, when the container here is covered with a clear plastic sheet, okay, the temperature here will be higher and the temperature here will be lower, right? So you can say that is why there are two differences here. Okay, there are differences in Q, right? It goes up, it increases, but it increases at a lesser rate as compared to Q. Okay, and then part B state two variables which must be kept the same throughout the experiment. Okay, right? So this is they're asking you about the fixed variable or the constant variable. Right, let's take a look at the answers here. Okay, so A, obviously the answer Q, right? Does everybody got that? Everybody got that? Q? Is it Q or P? All of you get that? Okay, very good. Okay, then how do you explain, right? Remember, this question asks you to explain. You cannot just state the answer, whether graph P or Q. Even though you get the correct option, right? They will still give you 0 marks. Okay, that is the PSLE marking standard. Right? If you answer this correctly, it doesn't carry any marks at all, not even half mark. Okay, you must be able to explain clearly why. What's the reason? Because they do not want you to give a fluke answer, right? They want you to ensure that you understand the concepts and able to answer correctly. Okay, so as the time increases, the air in container A gains heat from the light bulb, but some heat escapes through the opening at the top of the container. In container B, the heat is trapped by the clear plastic sheet, and hence the increase in temperature is higher. So you can see here there is a comparison. You need to compare. Okay, the increase in temperature here is higher. Why? Because here the heat is trapped and it is covered. Why? Because it is covered with a clear plastic sheet. Okay, so you must compare. So Ying asks, what if it's not a fluke? Okay, nobody knows whether it's a fluke or not, right? Okay, so to confirm that it's not a fluke, you must be able to explain correctly. Okay, if you're able to explain correctly, yes, no problem. You get the full marks. Okay, so that's why the examiner wouldn't know whether it's a fluke or not unless you are able to explain or you answer completely everything. Okay, part B, they ask you what variables must be kept the same throughout the experiment. Okay, there are many change variable, many fixed variable. Everything else other than change variable must be fixed, right? One is the type of container must be the same. It must be made of the same material. It must be of the same size. The distance between the bulb and the containers, the type of the bulb. Okay, everything must be the same except for the presence of the clear plastic sheet. Okay, this is very simple. Huh? All right, let's move on to the next question. Okay, again, this is a past PSLE question on the topic of light. Okay, on the topic of light. So I give you 1 minute to read through the question. Okay. All right. So Justin walked in a straight line from P to R as shown in figure 1 below. At Q, he was directly under the lamp. The distance between P and Q is the same as the distance between Q and R. Okay, so take note here, this very important point. The distance between P and Q is the same as distance between Q and R, right? So this is the same, right? These two are the same. Okay, the graph below, right? So this is a straight line graph, but there are two. It goes two ways, right? It's a kind of a V shape. Right? One is downward sloping, and after this point, it will be outward sloping. Okay, so figure 2 shows the length of Justin's shadow on the ground change during his walk. Okay, so did Justin walk faster towards the lamp or away from the lamp? Okay, how is it? By watching the shadow, right? So when you see graph, you need to identify what are the variables, right? What are the x variable, the horizontal axis as well as the vertical axis. So here the time is the horizontal axis, right? And this is the length of the shadow is the vertical axis. So you can say that as the time increases, the length of the shadow decreases up to this point, right? Beyond this point, right? Beyond this point, okay, this is 1, 2, 3 units, right? After the third unit, okay, from the third unit, 3, 4, 5, 6, 7, 8, 9, right? Beyond the third unit, okay, there is increase in the length of the shadow. So how? By watching the length of the shadow, you can tell the speed of how Justin walked. Okay, right? So here you have to be very, very observant. Okay, so in part A, did Justin walk faster towards the lamp or away from the lamp? Okay, so you can see here he was walking faster towards the lamp, right? Why? Because he takes a shorter time to walk the same distance, okay, PQ as compared to QR. Now this part here is very important. He takes a shorter time to walk the same distance. So you need to mention this, right? Because PQ and QR is the same, right? But in PQ, he takes only 3 units, right? In PQ, he takes only 3 units, okay? And QR, right, it takes 1, 2, 3, 4, 5, 6. It takes 6 units, right? It means that PQ, his speed is twice faster than QR, right? So by looking at the shadow, we can tell uh, which part did he walk faster, right? How? By seeing or timing, okay, taking the time taken for him to walk both distance, right? The first part here, PQ, he takes 3 units of time, and QR, he takes 6 units of time. So in your answer, you need to elaborate. This part here is very important. Okay, the same distance PQ as compared to QR. Okay, Qayyum asks, how to answer the question if they ask for relationship? Okay, so you can say that as time increases, the length of the shadow decreases. Okay, beyond or after point Q, right? After point Q, as time increases, the length of the shadow increases. So you need to explain with respect to the question, right? P, Q, R. Okay. All right. Now next question. Now this is a very easy. This is a multiple choice question. Multiple choice question. Okay. Now I give you 2 minutes to can get the correct answer. Okay, I know some of you have done before. This is a past PSLE question. Importantly, can you recall? Easy peasy. Okay. Namira say 3. Adam say 4. CY say 4. Okay. Those of you who have written down your answer, can you write down also your explanation? Why you choose number 3 or why you choose number 4? All right. Just the number itself is not enough. Can you write down your explanation? Why you say that the answer is 4 or why you say the answer is 3? How come you come to that conclusion? Waiting for your answers. Okay, Alia said iron is a good conductor of heat and can lose heat at a faster rate. Okay, remember, okay, now you say faster, already wrong already, right? Because you're comparing what? You're comparing 3 objects, 3 setup. Okay, so you need to say that iron is the best. I told you 1,000,000 times and you make mistake 1,000,000 times also. Okay, so when you are comparing more than 2 setup or 2 objects, you must use the proper comparative or superlative words. Okay, right? Iron is the best conductor, right? Best, cannot say better conductor, or you cannot say iron is a good conductor. Even though it's correct, right? Iron is a good conductor, but in this particular instance, you must say that iron is a better, or iron is the best conductor of heat. Okay, let's see some of your answers. 4, because iron is the best conductor of heat and transfer heat the fastest. Now, most of you say about the iron. Okay, so all of you agree, right, that since iron is the best conductor of heat, iron will the heat loss here will be the greatest in setup B. Now let's see where setup B is the least. Right? So you agree that either these two is the answer, and we will use elimination technique. Right? Remember elimination technique? So I'm going to cross out this. Now, elimination technique is very, very, very important in MCQ. It saves us a lot of time, right? So once we identify that we know that iron is the best conductor of heat, we know that the temperature of the water in setup B will be the least. We can straight away eliminate option number 1 and option number 3. So now we need to decide between number 2 and number 4. Now, why do you choose number 4? Okay, if you say C, now C, iron, wood is also the poorest. Yes, this is also the highest, right? This is the highest, but it still doesn't answer the question. All setup is losing heat. Yes, okay, very good. Now, this is not possible, right? This is not possible. Why? If you see here, it's a straight line graph. It means that as time increases, the water in setup C doesn't lose heat at all. Right? It doesn't lose heat at all. Now, is that possible? No, right? Because wood is a metal. Even though it is a poor conductor of heat, but still the water inside will lose heat gradually. Okay, even though it's slower than the rest, but it will still lose heat. So not possible for C to have a straight line horizontal graph. Okay, so that's why you know that the answer is number 4. Okay. Right. So here you can tell that you eliminate option 1 and option. Okay, this is another way to look at it. You eliminate option 1 and 2 because water in setup C will also lose it. Okay, so this is another elimination. If you look it this way, now some of you may look it this way also. You observe that A and C is not possible to have a straight line graph. Then from there, when you compare 3 and 4, yeah, you know that iron is the poorest the best conductor of heat, and hence the water in setup B will lose heat the fastest. Okay, all right. Okay, we have come to the end. Now is 8:53. Okay, so we have time for open-ended. Sorry, not open-ended questions. We have time for Q&A. Now, any of you have any questions? It's already 8:53. Yeah, time passes very very fast. It's almost 9 o'clock already. Didn't feel like an hour. Yes, that's the fun part about online webinar. So that's why I enjoy teaching all of you webinar. I can, more of my students can attend. We have, even though about 50 sign up, but we only have 41, but I'm very happy. Usually in our class, we have between 8 to 15 students, but I'm very happy that I can see lots of you in this session. Okay, if you have any question, can you please write down in the chat function? Why iron lose heat faster? Okay, here we are comparing iron and glass, as well as iron and glass and wood, right? So we know straight away, even though you may not know, but from your experience touching iron, right? You know that iron the best conductor of heat, right? Because why? When we touch iron, we feel cold, right? Our hand feel cold. Why our hand feel cold? Because iron is a good conductor of heat, so it gains heat from our hand very very quickly. Okay, and compared to wood, if we touch wood, we feel as cold. If we touch glass, do we feel as cold? Yes, glass also will be cold, but it will not be as cold as when you touch iron. Okay. Okay, any other question? This time I'm trying to scroll up also. If you have any question, I'm trying to take a look at your question. Okay, Shahinda asks, if they don't give you the aim in the question, how do you identify it? Very good question. Anybody can answer Shahinda. Shahinda asks, if in the question they do not give you the aim of the experiment, right? What would you do? Shahinda asks actually a very good question. Huh? Okay, if the aim of the experiment is not given to you in the question, how do you identify the aim? Right? Remember, I told you aim is very, very extremely important. By looking at the change variable. Yes, Nafisa, Alia, very good. Right? In fact, I think I've mentioned this yesterday. Right? If the aim of the experiment, sometimes they make it very difficult for you. They do not give you, they do not state clearly what's the aim of the experiment. Now, the clue is by finding out what is the change variable. Now, change variable is not very difficult to find, right? Remember, in the question, in any question, in any experiment, there can only be one change variable, right? So in this question, right, this MCQ question, what is the change variable? The type of material of the container, right? We can see that the only difference is the type of container, made of glass, made of iron, made of wood. Okay, so in this question, what is the aim of the experiment? What is it? You identify the change variable. Again, what's the change variable? The presence of the clear plastic sheet, right? So once you have identified the change variable, then you know that the change variable must be inside your aim, right? You must know that the change variable must be in the aim of the experiment, right? So in this particular question, what are they trying to find out? They're trying to find out if the different material of the containers affects how much the water loses heat, right? How much the heat is lost, how much heat is lost in the water in the container. So you can see here the same size and the thickness, right? The size and the thickness of the container is the same, right? Because these are the constant variable. These are the fixed variable. The change variable is the type of material. Okay, let's take a look at the next question. If there's no CV, change variable, and if there's no change variable, impossible. They, in an experiment, someone asks, teacher, what if there's no change variable and there's no aim? Impossible. In any experiment, there must be a change variable. Change variable is what we call also the test variable, right? If there's no test variable, then what are you going to find out? Right? Example, now let's say in this particular question, Everything is exactly the same, including the type of material of the container. They put iron, iron, iron. Everything is the same. So what are you trying to test? Right? So it doesn't make sense, right? In an experiment, you must test something. When you test something, there must be a change variable. So it's not possible that an experiment have no change variable. Yes, there must always be a change variable. Huh? Will a black color cup lose heat faster compared to a white color cup? Okay, yes, right? Why? You have experienced this before. If you are going out in outdoor, right? Let's say you're going to Universal Studio, right? In a very hot sun in the afternoon, would you wear black color t-shirt or white color t-shirt? The answer is very obvious, right? You will not wear black color t-shirt. Why? Because black color t-shirt absorbs lots of heat. When it absorbs lots of heat, so you feel hot very quickly compared to white color. It has to do with the colors, the reflection of the heat, right? How the heat is reflected, or how the light is reflected. Okay, so black color objects, yes, they absorb lots of heat as compared to clear or white color objects. Okay, how you answer if they ask for a control setup? What must you do? So control setup, right? Not all experiment has control setup in the question. So you need to observe. Usually they will ask you, why is this a control setup? Right? Why is it a control setup? Remember what's the control setup for? Right? To compare and confirm that the result of the experiment is only due to the change variable, right? You need to have a control setup. Is black color same as dark color? Yes, black color, dark blue, black, right? So the darker it is, the hotter you will feel because it absorbs more heat as compared to lighter. Lighter color doesn't mean just white, right? It could be light green, light yellow, all these are fine, right? Okay. How can you be sure that wood is the poorest conductor of heat and not glass? Okay, again, you may not know. Okay, all right, from experiment, have you touched glass and touched wood before? Right? Real life, right? If we touch wood and glass, we know that glass is a okay. We know that glass is cooler, right? It feels cooler, right? Because from there we can tell that glass is a better conductor of heat compared to wood. Okay, so again, when you see such question, right, you use elimination technique. If you use elimination technique, you don't have to think about all the various answers. Okay, you zoom in, right? Remember, in the exam, time is very, very important, right? Some of you think a lot, right? Why is this like this? Why is this like this? You don't have time to think during your exam, right? You can take note, right? You need to focus on the answer and then move on, right? Don't ask, hey, how do I know that iron is this? Why wood and compared to glass, right? So using elimination technique, you know the answer is number 4 and forget about the rest, move on, right? Example, we have past PSLE question. They give you a figure or an animal which looks very strange. So are you going to ask, hey, what animal is this? What, right? Why is this, the shape is this way, right? You don't have time to think of all those, right? Because you are not experienced in life enough, right? We do not know every single, not possible for everybody to know every single thing, right? They do not require, the best part is that PSL, they do not require you to remember very specific information other than your syllabus, right? As long as in your syllabus, okay, it will be tested, and anything which is not, which is beyond your syllabus will not be tested. So you don't have to know, like for example, you don't have to know about, what is the gravity of Earth, what is the gravity of Moon, very technical details you don't have to know because it will not be fair to test, right? Unless it is in the syllabus. Okay. For relationship question, must it be a graph? It depends on the question. Some question they just show you a table, and some question they give you a graph, right? So both are fine. You can see both types of situation. They may just give you a table, and you must be able to interpret the table, right? Now, what's the difference between graph and table? Now, graph can show you the trend much better. Okay, graph can show you the trends much better, right? You can see whether is it going upwards, going downwards, right? And you can compare better as compared to table. Okay, so usually in a scientific experiment, scientists will present both, right? First in the table form and then present in the graphical form. All right, so but in your PSLE, sometimes they only show you graph form or sometimes they give you only table form. All right, but in reality, real scientific experiment, it is usually presented in both table as graphical form. Okay. They will never give circle graph. Circle graph, yeah, you have already learned, right? In maths. So anything that you have learned in maths, they can ask you, okay? All right. And I don't think you have any problems if they give you a pie graph or circular graph. Okay, so don't worry about it, right? One situation that I can think of is the composition of air, which is very easy, right? Composition of air, which consists of how many percent of oxygen, how many percent of nitrogen, carbon dioxide, and so on. Okay. Okay, can a magnet totally lose its magnetism when we break it, burn it, or drop it? Yes, yes, can. If a permanent magnet, if you drop the magnets many times, okay, it can lose its magnetism totally. Okay, you heat it up, okay, it can lose its magnetism totally. Yeah. All right. It's already 904. Okay, 904. Okay, thank you very much, everybody. Okay, thank you very much. Okay, I hope that you have a very good rest, and I hope this session is beneficial. Okay, I know it's nothing new to many of you, but some of you are still not very sure. Okay, so it's very good. You can always ask me question. We have, I will see you this weekend. Is the fourth lesson for those students on the Saturday and Sunday classes. Okay, we will be giving away Children's Day prizes. For the P6 students because after this week it will be I may not be able to see you. So Children's Day is after your PSLE. Okay, so I've asked the vendor to give you the or to deliver us the Children's Day gift quickly. Okay, so this weekend you get all the P6s, you get your Children's Day gift very early. Okay, all right. Thank you very much, everyone. Bye bye, and have a good rest.